Good morning, students. We are continuing the chapter Magnetic Effect of Electric Current. Previously, we have studied the properties of some properties of magnetic field lines. Now, today in the detail, we'll see about what are the magnetic field lines. Now, if we see the direction of the magnetic field lines, if you see, it starts from the north. This is outside, and this is the inside the magnet. Outside the magnet, if we see, it starts from the north pole and ends at the south pole, but inside the magnet it starts from the south pole and ends at the north pole. This magnetic field line, these are the closed and continuous curve. If you see, these are the closed and continuous curve. No two magnetic field lines will intersect with one another. Why? Because if they intersect, they will show the two direction at the one point, which is not possible. Now the number of the line will represent the strength of the magnetic field. If the magnetic field lines are closer to the magnet, it means it is a stronger magnetic field, and as we go away from the magnet, it means the magnetic field line goes on decreasing. These magnetic field lines are parallel and equal in distance with one another. These magnetic field lines have the equal distance with one another. This shows that the magnetic field lines are uniform. Okay. First point, they travel from north pole to the south pole outside the magnet, and south pole to the north pole inside the magnet. So outside magnet, the direction is from north pole to the south pole, and inside it is from the south pole to the north pole. The magnetic field lines are the closed and continuous curve. Two magnetic field lines never intersect with one another. If the line intersect, at the point of intersection there would be two direction, which is not possible. So first point, it is of the direction of the magnetic field. Second is the shape, they are the closed and continuous curve. Third, no magnetic field line will intersect with one another. Next, the number of field lines per unit area is the measure of the strength of the magnetic field, which is maximum at the pole. If you see at the poles, these are the poles, the magnetic field will be stronger at the pole, but as we go away from the pole, the magnetic field goes on decreasing. So it varies with the distance from the magnet. Fifth point, magnetic field lines are parallel at an equal distance with one another. This shows that magnetic field is uniform. Last, if we draw a tangent to the magnetic field lines at any point, it will give the direction of the magnetic field at that particular point. For example, if this is the magnetic field line, and if we draw a tangent, so if we see, if it is coming from the south, it is coming from the, suppose, north pole. If this is the north pole and this is the south pole, then this will be the direction of the magnetic field. If we draw a tangent, this tangent will show that this is the direction of the magnetic field. So what are the first properties? This travel from the outside magnet, it travel from north pole to the south pole. Inside it will travel from the south pole to the north pole. These are closed and continuous curve. Two magnetic field line never intersect, because if they intersect, it means they are showing two direction, which is not possible. The number of the magnetic field line per unit area measure the strength of the magnetic field. The strength of the magnetic field, the closer to the magnet, the magnetic field are strong, but as we go away, the magnetic field goes on decreasing. Magnetic field lines are parallel and equal distance with one another. This shows that the magnetic field lines are uniform. If we draw a tangent to the magnetic field, then this tangent will show the direction of the magnetic field.